Solutions. A solution is any homogeneous mixture that can be made up of almost any two phases of matter. Solid, liquid, it could be liquid, solid, gas. So there can be any two phases of matter. A solution is made up of solute and solvent. The dissolved substance is the solute and the substance it is dissolved in is the solvent. For example, if you take pinch of salt and you dissolve it in water, then salt is the solute and water is the solvent. Like dissolves like, and we have discussed this before in previous classes, that polar compound dissolves in polar and non-polar dissolves in non-polar. Most ionic compounds, they are highly polar, so they will dissolve in the polar solvents. If you look at the next if you look at the example number 1, which solvent liquid, ammonia or benzene? So we have these two different solvents, ammonia and benzene. Ammonia is polar. Why? Because of dipole and hydrogen bonding. And if you look at the formula C6H6, benzene made up of carbon and hydrogen is a non-polar solvent. So water is polar, so polar dissolves in polar. This compound C6H12, if you see, it's made up of just carbons and hydrogens. So that means this is going to dissolve in benzene. Silver chloride, ionic compound, dissolves in polar. Now, solubility of solids. Most gaseous and solid solutes, they dissolve to an extent in a given liquid and at a given temperature. This tells that the temperature has an effect on the solubility. Now, for example, the solubility of boric acid at 30 degrees Celsius is 6.35 grams per 100 grams of water. So that means if you take 100 grams of water and you put 6.35 grams of boric acid, it will completely dissolve. What will happen if you will add a little bit more? Then the extra added one is not going to dissolve. But this extra added one, you can dissolve it if you increase the temperature. So what does that mean? This means that the solubility of solids in liquids increases with the increase in temperature. But that's not the case with the gases. In the case of gases, the solubility of gases, or you can say the solubility of even solids to gases, solids in liquids or gases in solids, decreases as the temperature increases. So for example, you can take the case of soda can. In that case, it is liquid. You have a liquid, you have a gas on the top. If you will increase the temperature, the gas is not going to dissolve more in the liquid. Instead, it is going to, it's not going to be soluble and it will escape. And why is that? Why the gas's solubility decreases with increase in temperature? Because once you are increasing the temperature, now the molecules have greater kinetic energy, so they want to escape into the gas phase or go far away from each other to become stable. Now, what is concentration? It is a quantitative way of expressing quantitative, if I can write it correct. Let's write it here. Quantitative way of expressing solution. There are different ways to express the solutions. The ones you have to know. The first one is percent by mass. It is the mass of the solute divided by the mass of entire solution. This is very important. Not by the solvent, but by the solution times 100. So for example, if you look here, this is a very simple question, because in this one we are given 285 gram of solution. We are given 85 grams of solute. So all I have to do is percent mass equals 85.0 divided by 285 times 100. Your answer should be 29.8%. Make sure the solution is written here, because if it's going to say solvent, then to find the mass of the solution, you have to mass of solute plus mass of solvent. But that's not the case here. Another way is to find the concentration is molality. Now you have done molarity before, and why I'm not talking or discussing molarity here, if you remember, molarity is moles by volume, and volume changes with the temperature. So we are trying to discuss the ways here that are independent of temperature. So percent by mass, molality, all the methods that I am discussing here are independent of temperature. So molality is denoted by lowercase m. Molarity was uppercase m. And what is molality? It is the moles of solute dissolved in a kilogram of solvent. So that means you want your solute in moles and solvent in kilograms. So look at this question. Calculate the molality of a solution prepared by dissolving 29.5 grams of salt in 212.7 grams of solvent. So water is the solvent. So all I have to do is convert this solute that's given in grams to moles, and that will go here by using the molar mass of NaCl. And this is a solvent, but we are dividing with the kilogram, so I have to convert this into the kilogram by dividing it with 1000, so which is going to be 0.2127. So these moles, so once you're going to convert these into moles and convert that into solvent, your answer should be, let me make sure, your answer should be 2.37 molality. Your moles should come out after you're dividing it with the molar mass of NaCl, which is 58.5. It should be 0.505 moles divided by these many kilograms should give you molality. Now, there are so many factors here. Here's the molality, here's the moles, kilogram of solvent. So if you look at this question, calculate the mass of fluoric acid needed to make, perchloric acid needed to make 5.13 molar solution in 239 grams of water. So if I go back and write down the formula, molality equals mole of solute divided by kilogram of solvent, and the solvent is given here, which is 239 grams. In kilograms it is 0.239 kilograms. And I'm also given molality the mole fraction. The mole fraction is basically the number of moles of a particular component divided by the total number of moles. For example, let's say you have a solution made up of A and B, and if you want to find out the mole fraction, this is the way we show mole fraction. So you want to find out moles. So how will you find out the mole fraction for component A? You take moles of A divided by the total moles. If you want to find out the mole fraction for B, that means the moles of B divided by total moles. The sum of the mole fractions of any solution is always 1, and it has mole fraction has no unit. Why? Because you're dividing moles with moles. Now, that means if your solution is made up of only A and B, that means the mole fraction of A plus mole fraction of B will be equal to 1. So, look at this problem here. Calculate the mole fraction of methyl alcohol. You have in a solution, you have 1.46 moles of methyl alcohol and 2.19 moles of ethyl alcohol. You have to find the mole fraction of ethanol also in the same solution. So mole fraction of methanol will be moles of methanol divided by total moles, and which is going to be this, and mole fraction of ethanol, which is C2H5OH, that will be equal to 2.19, which is moles of ethyl alcohol divided by total moles, and that should be 0.600. And if you look, this is made up of these two things, and if you add them, it is 1, because we said the sum of the mole fraction is always 1. Converting between concentration units. Converting between concentration units. So what does that mean? We discussed percent mass, we discussed molality, we discussed mole fraction. So what if information is given in terms of molality? You have to find mole fraction, or percent mass, you have to convert it to the molality. This is called the converting between concentration units. So here in this question,